So good morning, sir. Good morning, sir. Sir, good morning, sir. Hello. హలో వెంకట్ గారు వాయిస్ రావట్లేదండి. ఎవరిది వినిపించట్లేదు సార్. సార్ హెచ్ఓడి సార్, ఈజ్ మై వాయిస్ ఆడిబుల్? నేను ఫోన్లో మాట్లాడుతున్నాను సార్, జూమ్లో వినిపించట్లేదు సార్. సార్ పిఎస్ గారు చెప్పండి సార్.
కరోనా వైరస్ లేదా COVID-19 తో ఈరోజు దేశం మొత్తం యుద్ధం చేస్తోంది. కానీ గుర్తుంచుకోండి, మనం పోరాడాల్సింది వ్యాధితో, రోగితో కాదు. వారిని వివక్షతో చూడకండి, వారిని పరిరక్షించండి. ఈ వ్యాధి నుండి మనల్ని కాపాడడానికి రక్షణ కవచాలు డాక్టర్లు, ఆరోగ్య కార్యకర్తలు, పారిశుద్ధ్య కార్మికులు, పోలీసులు. వారిని గౌరవించండి, వారితో సహకరించండి. ఈ రక్షణ కవచాలను పరిరక్షిద్దాం. కరోనా వైరస్ నుంచి దేశాన్ని గెలిపిద్దాం. మరింత సమాచారం కోసం రాష్ట్ర హెల్ప్ లైన్ నెంబర్ 104 లేదా కేంద్ర హెల్ప్ లైన్ నెంబర్ 107 సంప్రదించండి. భారత ప్రభుత్వం ద్వారా జనహితార్థం జారీ.
సార్ అదే వాయిస్ వినిపించట్లేదు సార్. నేను మీకు ఫోన్లో మాట్లాడుతున్నా సార్, నాది వెబినార్. అవునా, ఓకే సార్. అయితే సార్
ప్రసాద్ గారు,
సార్ అదే సార్, నాది ప్రాబ్లం చూస్తున్నాను సార్. సెల్ ఫోన్ ద్వారా కనెక్ట్ అవుతుంది సార్. ఓకే సార్. ఓకే. వెంకట్ గారు చెప్పండి. హలో.
Grand morning to all the eminent dignitaries, respected delegates, and to our dear GITAM family. इस समारोह में उपस्थित सभी देवियों और सज्जनों को मेरा आदरणीय प्रणाम. India is towards This dream is deep-rooted and far-fetched, as we all know. This precisely suits our virtual seminar. Dear ladies and gentlemen, on this day, the 28th of August, 2020, I, Dr. Padmini R., extend a very warm welcome to all of you on behalf of the Department of Mechanical Engineering, GITAM Institute of Technology, GITAM deemed to be University, to a 2-day seminar entitled Exciting Advances in Manufacturing Automation 2020. Knowledge gives humility. Humility instills character, from which wealth, good deeds, and happiness follow. Such is the power of knowledge. EAMA 2020 is the strong platform to disseminate collaborative insights from various knowledgeable sources on advances in manufacturing automation. On a very optimistic note, I request the igniting power of the Department of Mechanical Engineering Professor Emeritus Satyanarayana Sir, Head of the Department, to join the panel. Good morning, sir. With immense pleasure, I invite our beloved Principal Sir, who is the focal point of motivation of GITAM Institute of Technology, Professor C. Dharmaraju Garu, to grace the occasion by joining the panel. Namaste and good morning, sir.
You will join later. You will join later. Next.
Yes, sir. Fine. With deep sense of respect, I now request our highly respected and regarded Professor Vijay Shekhar Chellaboina sir, Dean Engineering, GITAM, to grace the eve and join the panel. Namaste, sir, and very good morning.
Thank you. Good morning. Thank you.
In tough times, this consistent and persistent energy, which can hardly be described by words, phrases, or sentences, has been and is still the driving force of GITAM. The other name, the strong, encouraging, and empathetic force is our dear Honorable Vice Chancellor, Sir, Professor K. Shivaramakrishna Garu. Sir, please grace the occasion. Namaste and good morning.
Good morning.
Thank you, sir. Deepa Jyoti Parabrahma, Deepa Jyoti Janardhana, Deepo Haratume Papam, Sandhya Deepa Namostute. Let us all join our hands for virtual Jyoti Prajwalan.
Kalyanam Arogyam Dhanasampadah Shubham Kurutvam Kalyanam Arogyam Dhanasampadah Shatrubuddhi Vinashaya Deepajyotir Namostute Deepajyotir Namostute Deepajyotir Parabrahma Deepajyotir Janardhanah Deepajyotir Parabrahma Deepajyotir Janardhanah Deepo Haratu Me Papam Sandhya Deepa Namostute O Deepa Brahma Rupastham Jyotisham Prabhuravyayah O Deepa Brahma Rupastham Jyotisham Prabhuravyayah Arogyam Dehi Putrasya Matim Swachham Hi Me Sada Raverastam Samarabhya Yavat Suryodayo Bhavet Raverastam Samarabhya Yavat Suryodayo Bhavet Yasya Tishte Druhe Deepam Tasya Nasti Daridrata Shubham Kurutvam Kalyanam Arogyam Dhanasampadah Shubham Kurutvam Kalyanam Arogyam Dhanasampadah Shatrubuddhi Vinashaya Deepajyotir Namostute Deepajyotir Namostute Shubham Kurutvam Kalyanam Arogyam Dhanasampadah Shubham Kurutvam Kalyanam Arogyam Dhanasampadah.
Okay, madam. Next.
I now request the convener of EAMA 2020, Dr. B. Srinivas Prasad sir, to present the report of the event.
So, good morning, sir. Thank you for giving this opportunity. Honorable Vice Chancellor GITAM, Professor K. Shivaramakrishna Garu. Good morning, sir. We were very much thankful to you, sir, for your presence. And respected Dean Engineering, Professor Vijay Shekhar Chellaboina Garu, and beloved my HOD, Dr. Emeritus Satyanarayana Garu. Very good morning, sir. On behalf of Department of Mechanical Engineering, as a convener of this particular two-day event, myself, Dr. Bala Srinivas Prasad, inviting you everyone for this two-day virtual seminar series. Sir, I just want to start with a small example, sir. Irrespective of the country and the continent, everyone is right now suffering with a problem called COVID-19. I'm not talking about the medical solution. I'm talking about the involvement from our side. We belong to this particular branch, that is mechanical engineering. To support the sustainability of the society, we need to identify the COVID patient with the non-COVID patients. We need to segregate the patients. For that particular purpose, there is a specific device which required, that is called nasal swab. This is the device which required in huge in number. If you consider the numbers around the world, daily you need to go for the testing of the COVID patient, then only you can safeguard that we can ensure the sustainability of the society. And this particular nasal swab is a device which must be flexible. It should have all the required mechanical properties at different levels. It will be inserted into the nose of a human to a longer distance than expected. So it should travel in a parabolic shape. So the device must have some mechanical properties. And this particular device is fabricated by a particular technique called, under the hub of mechanical engineering, under the substrate from the mechanical engineering, a 3D printing technique is used to produce a nasal swab. This particular device is in huge in demand for the next 4 years or 5 years, if you consider. So, and this particular device is fabricated using a technique called 3D printing, and that is part of the manufacturing. And this particular 3D printing techniques requires expertise of the 3D modeling and the design principles, and expertise in the field of manufacturing. The people with the design and manufacturing knowledge will be the more prominent features in the coming days. So we are not giving the scientific solution. As engineers, we are trying to contribute to the society for sustaining with facing the current situation. That is about the crisis. So with this objective, I would like to introduce I would like to mention the reason behind this particular today event. That is exciting advances in manufacturing automation. So generally we used to, as a faculty, we used to go through the Google Scholar or ResearchGate. So I used to follow Dr. Naveen Kumar sir profile since 2015. If you can observe his publications up to 2018, his publications are mainly around the vibration related applications. Recently, during the month of May or June, myself and Sandeep, or my co-coordinator, we are randomly exchanging some messages. We have identified a particular title of the one publication. I just going through the reading out the title of the publication. Lessons from mosquitoes, painless piercing. If you can understand this particular sentence, we can expect this particular publication must be from a medical doctor. Then I have verified who is the author of that publication. Then I came to know that the person who is an expert until then in the vibration, he has published that particular paper. He is none other than Dr. Naveen Kumar from IIT Ropar. Actually, the combination of mechanical engineering, he went to so much deep into the medical field. It really, the particular issue has excited me a lot. So myself and Sandeep has decided to use this particular word, exciting. Now, one of my PhD scholar who is working under me at the GITAM University, I came to know about a most famous doctor in Hyderabad. Actually, he is famous in the celebrities. Most of the celebrities in our Telugu speaking states are clients for him. We very occasionally we used to exchange some information over the social media. And I came to know that he has a habit of documenting his data. Whenever he treats a patient for his facial surgeries, he used to save the data. Whatever the scan data he collects as part of the critical surgeries, he has the habit of saving the data. But recently, I came to know that he started converting the documented data into the publications. And we were able to collaborate with, I'm able to collaborate with Dr. Arvind also. So that is why we have, I think he is the right person to show the integration between the mechanical engineering in the field of dental application. That is why we have selected Dr. Arvind as one of the invited speaker for this particular 2-day event. Then recently, from the academic year 2020-21, my department has proposed, my department, that is the mechanical engineering department, has started, they have started introducing the new MTech program called Manufacturing Technology and Automation. Now, being the person who belongs to the mechanical department under the stream of manufacturing, we want to launch this particular program in a best possible way. So whatever the activity we are trying to do, we will try to focus towards the manufacturing. That is the main intention. So that is why we thought of including one expert in the field of manufacturing. Then, based on the Google Scholar Metrics, we found one particular faculty. His last 10 publications are SCA publications. Based on the Google Trends, we have selected. And he has some connection with the GITAM also. His guide is from GITAM University, Dr. B.S.N. Murthy Scholar. And we have selected Dr. K. Venkatrao from Vigyan University as another speaker to focus on the manufacturing stream. Now, so far we, myself and Sandeep were thinking about conduct a 2-day program. And because as part of the, our President Sri Bharatigar has his focus area is to promote the event, create an ambience so that the students will come and connect to the campus. So that is why we were not sure about the classwork in the month of June. When the college is going to be reopened, there is no clarity on that. For the last 2 weeks, we had enough meetings about the digital learning and everything, in which the President and VC has clearly conveyed that the classwork will be commenced from 17th August. So we thought this is the right time to launch our program. That is why we have selected 2 days, that is 28th and 29th of August, because 28th is I don't have classwork on the 28th, and 29th is a holiday, public holiday. So that we are expecting a lot of participation from the audience. Now, up to this, we are talking about a virtual seminar series, because GITAM University has provided us unlimited access to the Zoom platform. We want to use in a maximum possible way, in a productive manner. This is what we thought as part of the FTB and the productive tools. Then up to here, after consulting the approval from the Dr. Naveen Kumar from IIT Ropar, Dr. Arvind from Hyderabad, Professor Venkatrao from Vigyan University, we thought of conducting only the virtual seminar series. Then, being a manufacturing engineer and a mechanical engineer, we need some industrial exposure. We are searching for an expert with industrial exposure. Luckily, we got the acceptance from Dr. Fayaz bin Turan from Malaysia, University of Malaysia. He has the experience of nearly 12 years at the industry level. Last 7 years, he is into the academics. We are looking for the industry expert, but we got the opportunity to include both the industry and the academic experience. And he gave the acceptance. So he is going to focus on the decision-making methods. So Dr. Naveen Kumar has excited a concept, and the Dr. Arvind is going to take you the advances in the 3D printing, and the Professor Venkatrao is going to focus on the optimization in the various core manufacturing process. And the person who is going to give you the insight, the deep insight with the industrial exposure on automation is none other than Dr. Turan from Malaysia, University of Malaysia, Penang. So that is how we have selected the 4 experts based on the research profile only. Now, we have launched this particular website by getting that exposure through FTP training. Myself and Sandeep has created all the forms by using the Google Forms, and we were able to use the add-on tools also. So with this, we have launched with the consent of HOD Mechanical Engineering, we have launched this particular concept to the audience. Initially, we thought of conducting up to 300 members. Actually, we took the permission to conduct a seminar for 2 days for 300 members. Unfortunately, due to the single word called, due to the name of the call GITAM University and the experts we have chosen, we have received 3 times the expected response. Till now, I have received the response 780 members, 780. Just now, today at 8:30 we have closed the registrations. I'm talking these particular numbers with respect to the response which we have collected at 8:30 a.m. Out of 780 participants registrations, we received participation from 19 states in India, across India, 19 states. And I'm happy to share that, sir, to the submission of the Vice Chancellor, sir, we are able to get response from 5 different countries, sir. Even the number is in single digit. We were able to receive the response from 5 different countries like France, Canada, Papua New Guinea, Netherlands, and UAE, sir. Now, out of the 780 participants, only 200 members from GITAM. Because our classwork is in a hectic state, we are not allowing the students for 2 days. Whenever they are free, they are allowed to come into the session, as per my HOD's advice, sir. And surprisingly, we received a participation from 35 members from GITAM Dental College and Hospital, sir. This is due to our colleagues in the GITAM University. Thanks to the support from the GITAM Dental College, sir. And we have received participants from across the India. 286 are faculty members, sir. With the doctorates, they have joined 286 with the doctorates. And 40 PhD scholars also registered who are under active PhD program. And across the state, across India, we have received 291 responses from the undergraduate students, and 76 from PG students, and 26 from practicing engineers, sir. We have stopped the registration. We can expect more registration. Sir, VC sir, you asked me to complete 1,000 members, but we are fell short of that particular number, sir. But as per my initial expectation, this is beyond the expectation, sir. Please forgive me on this, sir. Sir, at the outset, as a convener for this particular program, to the participant, I want to convey that the experts we have chosen from the Department of Mechanical Engineering, I can assure you that the expert we have chosen, they are going to satisfy your all requirements. If you are thinking about the research scope in the field of manufacturing and automation or 3D print and whatever may be the area, these are the experts, they are well equipped with real-time examples and case studies. Now, sir, one more my submission, sir. We have kept this name up to without the acceptance from the Muhammad Turan from Malaysia. We kept that as only the virtual seminar series. After getting the approval from the Muhammad Turan from Malaysia, we have changed this name as Global Virtual Seminar Series, sir. And even though COVID starts with COVID-19, it made a lot of trouble for the entire year 2020. To remember that particular thing, we have kept that as Exciting Advances in Manufacturing Automation 2020. Now, sir, my submission, we don't want to, as per my HOD's instruction, we don't want to stop here, sir. If the support and encouragement is from the GITAM University, higher authorities, we would like to continue this particular activity for every semester, sir. Because we have named it as a series, we would like to continue this particular activity by various substreams of the mechanical engineering. Whatever we are doing under the hub of mechanical engineering, manufacturing comes under the mechanical engineering substream. We want to continue that, sir, only with the permission of the higher authorities, sir. So thank you for giving this opportunity. And being an engineer, after 20 years of service in teaching and 45 years of age, today only, after the emergence of the COVID only, I came to understand why everyone says the mechanical branch is evergreen. I came to understand that it is even only branch in engineering, if the object of any engineering is to give the better compass to the society at the cheapest possible price, definitely we engineers, we are doing that. But as a mechanical engineer, I came to understand why our branch is evergreen. In spite of the presence of all branches in society, we are the persons with the mechanical engineering background through combination of design and manufacturing with the help of 3D printing. This is the only technique which can produce nasal swabs. This is the needed of the hour. That is why I understood that our branch is an evergreen branch. Thank you everyone for giving this opportunity, sir. Thank you, Vice Chancellor, sir, Dean, sir, particularly our HOD, for encouraging me like anything, sir. Thank you, sir. Thank you, everyone, sir. Thank you, all the invited guests who accepted my invitation. Thank you. Personally, thank you very much, sir. Thank you, sir. Thank you for giving this opportunity.
Yes, sir. Kudos to Mechanical Engineering Department. From the time we started studying it, we've always heard Mechanical Engineering mighty. These keywords were associated, evergreen as well. Truly interesting narration of all the facts and incidents which have converged to EAMA 2020 Global Virtual Seminar. Thank you, Dr. BSP, sir. I now request Professor MRS Satyanarayana, sir, Head of the Department of Mechanical Engineering and Chairman, EAMA 2020, to present scope, aim, and report of the Global Virtual Seminar. Sir, over to you.
So time is running. In fact, welcome to all members and most respected Honorable Vice Chancellor, Professor K. Sarankrishna Garu, in Engineering, Professor Vishakar Garu. Invitees, resource persons, dear delegates, good morning to one and all. I'm happy to invite all delegates and participants attend this 2 days global virtual seminar and gain knowledge and implement in your career. So this is because time is running. So Dean has some urgent work and the VC are also some urgent work. This is definitely useful to the engineers. Thank you. Madam, next.
Thank you, sir. I now request and invite Professor C. Dharmaraj Garu, Principal, GITAM Institute of Technology.
Madam, principal is not there.
Okay, sir.
Please
I'll
invite
move ahead. I'll move ahead, sir. Yes, sir. Okay, sir. I request humbly Professor Vijay Shekhar Chalaboina Garu, Dean Engineering, to pinpoint his remarks on this occasion. Sir, over to you.
Good morning, everyone. Welcome to this exciting advances in manufacturing and automation. It's probably a little bit of a secret that I'm actually a mechanical engineer. I got my BTech from IIT Madras and then did my aerospace engineering degree at Georgia Tech. Now, Professor B.S. Prasad was saying mechanical engineering is green, and it is in fact green. There's no question about it. I started as a mechanical engineer, ended up as an aerospace engineer, but what I do mostly is actually mathematics. So you have every field that is conceivable within mechanical engineering. If it's such a broad field that you can actually pick and choose what we like. And here's another secret that I want to share is basically I am a proud recipient of all D grades in my manufacturing courses. We had 3 courses in mechanical engineering, and I secured all D grades. Of course, when I say I'm proud with a smile. I don't mean it. It's one of those courses that it's never suitable to my type of interests. As I indicated, I'm more mathematical, and then manufacturing technology tends to be very descriptive oriented when it comes to examinations and things like that. Now, while we say mechanical engineering is green and everything, but it is a fact that mechanical engineering is not the most preferred field by the students these days. So it is up to all of us. I think many of us listening here, joining this particular conference are mechanical engineers and probably specializing in manufacturing. We should rethink in terms of how to make it cool. How do we make it a little bit more attractive? I mean, I don't think we need to even think for a second that it is a useful thing to do, right? I mean, there is a lot of need. The country needs, in fact, a lot of manufacturing, scientists or employees. But nevertheless, we are not attracting the best students to mechanical engineering. So we need to start thinking, how do we make our curriculum in such a way that it is actually better than what it is today? Well, better in the sense that it attracts students and give them confidence that actually they can secure jobs that are equally competitive compared to, say, what they are doing today. Many of them go for computer science or something similar simply because of salary, or there are many reasons, of course. So how do we make it? So we have to think and try to make our curriculum more interdisciplinary in nature. And of course, these are buzzwords, but eventually we as academicians need to figure out what's the best way to handle such things. For example, 3D printing, I'm excited to see Dr. Arvind to be part of this seminar. He's going to talk about how 3D printing is useful in dentistry. Right? And Dr. Naveen Kumar from IIT Ropar is a biomedical engineer, it seems, mechanical, but eventually turned out to be applied in biomedical. I myself have actually done some work in biomedical related to anesthesia. So there are so many interesting applications just in medicine for 3D printing and manufacturing in general. So these, instead of thinking of them as some special topics that are coming into a conference, we actually should start thinking how do we incorporate into our curriculum and actually, redefine mechanical engineering so that it is attractive to many students. So in the interest of time, I don't want to say much more than this. Welcome again. I hope you will have a fruitful couple of days of workshop, and I apologize. I have another meeting, so I'll leave soon and let you do this conference. Thank you.
Thank you very much, respected sir, for your insightful address. I now request our Honorable Vice Chancellor, Sir, Professor K. Sivaramakrishna Garu, to address the panelists and attendees. Sir, we are waiting for your words. Hearty welcome, sir.
Yeah, thank you. Very good morning to all of you. Data Engineering, Professor Cheshekar Chellaboina, and Head of the Department, Professor Amara Satyanarayana. The convener of the seminar, Dr. B. Srinivas Prasad, and co-coordinator, Dr. Sandeep. And the resource persons from different walks of life, Dr. Arvind from the medical profession, and Professor Naveen from academics and also research, and Professor K. Venkat Rao and Dr. Muhammad Turan from Malaysia. All the faculty from the Department of Mechanical Engineering and other departments, participants from academia and industry and research scholars and students, a warm and hearty welcome to GITAM University, particularly for this particular seminar. And let me congratulate the team who have initiated this particular seminar, Dr. B. Srinivas Prasad, under the leadership of Professor Amara Satyanarayana and Dr. Sandeep and his other members, who have conceived a very interesting theme for the webinar, exciting advances in manufacturing automation. It's really apt and also very interesting. And Dr. B. Srinivas Prasad has narrated how he has conceived and what made him to think about it. It's very interesting. The way he is explaining itself is exciting. So he has a lot of, it reflects his passion of doing this webinar, and it's showing his interest in his way of expression, how deeply he is involved, how he has put all his efforts to make it a grand success for the benefit of community. And as a Vice Chancellor, let me brief for the members, for the participants from the different parts of the country, different parts of the other parts of the world. And GITAM is named after Mahatma Gandhi, Gandhi Institute of Technology and Management. It's a 40 years old institute. As an university, it's a 13 years old university. And we have 3 campuses, Visakhapatnam, Hyderabad, and Bangalore. There are about 20,000 students are pursuing about 200 programs in different disciplines. We have almost all the discipline except agriculture. That is how it's a multidisciplinary university and catering to the needs of society and the corporate. And we have about 1,500 faculty, about 1,500 research scholars pursuing their highest academic qualification like MPhil and doctorate. And it's accredited by NAC with A+, and also recognized as a Category 1 grade autonomy university among very few universities, particularly in the deemed university status. Hardly 10 universities are identified out of 136 deemed universities. And GITAM, by understanding the changes in the higher education space across the globe and within the invented in 1700 of society. From agrarian society to industrialized society was developed because of mechanical engineering and mechanical principles which have been applied in production process. That's how we call it as an industrial revolution. Revolution which has brought a sea change in the life of human beings. In 1700s, it happened, and we are all witnessing how the society has changed from agrarian economy or agrarian society to industrialized society, and how the change has happened. The total social fabric has been changed because of a single principle of mechanical power. That is the strength of the mechanical engineering. From then onwards, it added lots of things, lots of developments have taken place and improved the quality of life of people in the society. That's how all mechanical engineers should feel proud of it. You are the prime mover and you brought the change in the society across the globe. And we should not stop with that. It's a continuous journey. In the process, what you have identified, this exciting advances in manufacturing automation is very much in need of the present day society. And the way we have involved a doctor, a researcher, and an academician and other gentlemen from industry is very much essential. Then only what all we are doing, it will reach to a common man in a way of different products and services. So that should be the ultimate objective of any engineering profession. So you have done a right job and appropriate thing. And this webinar definitely is going to bring insights and also a good understanding to the mechanical engineers, how we can collaborate with other disciplines and add value to your own engineering, mechanical engineering, and also add value to the other disciplines. This is the order of the day, and this is the future. An interdisciplinary work only can bring good quality products and services which are needed, which can solve the problems of the human beings and problems of the society. So this is the right time, and that's what we are expecting in GITAM University. The department should not work in their silos. They have to come out of their branch and embrace the other branches, other disciplines, so that the innovative ideas and innovative things will come out, which will be helpful to the society and to the corporate in general, to the human beings. So with this brief note, once again, I welcome all of you. I hope and wish this two-day webinar is going to be a great achievement or a great thing in all your academic activities and your academic pursuit. It will give a new direction to your thinking. And I suggest and request all of you to think in a new direction by taking this as a lead. And it will definitely add value to your profile, personal profile as an academician, and also add value to your institute where you are working. In turn, will give a benefit to the society. Thank you for giving me this opportunity. Thank you, one and all.
Thank you, sir. Thank you.
Thank you very much, sir, for your inspiring note. and igniting our positive energies on this eve. Moving swiftly ahead, I request Professor V. Srinivas sir from the Department of Mechanical Engineering to introduce our resource person, Dr. Naveen Kumar Ji from IIT Ropar. Sir, over to you.
A very good morning to all of you. Am I audible?
Yes, sir.
Yes. Yes.
So it's a pleasure to introduce Dr. Naveen Kumar, Associate Professor from IIT Ropar, Haryana. I'm just sharing the screen of his achievements. So Dr. Naveen Kumar is a mechanics, bone properties investigation, biological materials, structures, biometal characterization, experimental and simulation studies of nano and biomaterials. He published more than 60 publications in impact factor international journals. He presently has research collaborations with He published more than 60 publications in high impact factor journals. He has research collaborations with several international institutes like Stevens Institute of Technology, New Jersey, Henry Ford Hospital, Durham University, University of Aston, University of Glasgow, Binghamton University, Rensselaer Polytechnic. He is also collaborating with national institutes like PGIMER Chandigarh, CDRA Lucknow, AIMS New Delhi, Punjab University, and Nikar Mohali. We are glad to have you here, sir. Thank you very much.
Thank you very much, Professor V. Srinivas sir. So we are going to have an overview of Sir's profile, Dr. Naveen Kumar Ji from IIT Ropar. Our convener has started to share the screen. I request all the panelists and attendees to just be with us. We do know that we are on a very different and completely different virtual. Yeah, here it is.
Madam, please read it out.
Professor V. Srinivas sir.
Yeah, please.
Madam, you can do.
So we can just see on the screen, needless to say, sir has multidimensional experience, 60 publications in high impact factor international journals. It's evident. I request all the members to just go through and have a bird's eye view of Dr. Naveen Kumar Ji's interesting profile.
Okay, madam.
Shall we proceed, sir?
Yes,
Okay, madam.
Yes, sir. So we have just seen a very brief profile, and frankly speaking, if we directly interact with the person and if we listen to the words of the person, it's more interesting than looking at the profile of a person. Now, it's time for me to extend a warm welcome to Dr. Naveen Kumar Ji from IIT Ropar. Sir, Please cast your reflection on this eve. It's over to Dr. Naveen Kumar ji. Sir, हार्दिक स्वागत है आपका.
Thank you. Very good morning to all the people who have joined here. In particularly, I thanks the VC Vice Chancellor of the GITAM University, Professor Shivarama Krishna, the Dean, the Professor Vijay Shekhar, the HOD Mechanical, Dr. Satyanarayan, Professor Satyanarayan, HOD Mechanical, Dr. Shivaramakrishnan, Bala Shivaramakrishnan, Dr. V. Shivaramakrishnan, Dr. Sandeep. So many people has involved this and bring it to this stage that it is now possible to have this webinar. It's take a lot of efforts behind the curtains. So thanks you all people who has make it possible. Like people has already talked about it, that the mechanical engineering is very exciting, has so many dimensions, like Professor Vijay Shekhar was talking about, that it has so much potential, but still we are lagging in the attracting the talented students. Yeah, that's the very unfortunate thing which is happening. But I think we are also responsible for it. We have to modify, we have to bring some changes in our curriculum, in our way of teaching, or in our area. I can give you the example, like we still give the project to the BTech student, MTech student about the gear designing. Gear has been designed near 100 years back. So why we are still giving them such a topic which is not so much of interest to them? Bring some more things, maybe place a sensor like this conference talk about it. So and then they measure those forces which are coming on those gear teeth, and then they can have a better understanding of it. So automation, sensing, fabrication, all this domain, if we bring together, then I think we will make it more possible, attractive and useful to the industry, because industry is not like 50 or 60 years back. They have the cutthroat competition, so they want the technology involvement in the, and interdisciplinary is the major thing which should be come up. And mechanical is not only now only the metals, it has ceramics, composite, biomaterials, biomedical engineering. So many things are there. So that is the perception people has. We have to come across it, and we have to break those barriers. And then I think this branch will have definitely a bright future. But yes, some up and downs always come in all the branches, but we should not lose the heart. But it is very, very exciting to me to hear, and I know the GITAM University since long, and it's have a very good name and fame, and in particular Professor Shivarama Srinivas has interacted me so many times, and it's really exciting that people are so much interested in the research also. So that's the beauty of it should be happen in this country, because the so-called buzz about the IIT should not be there. The other institutes are also doing very good, but they should be bring in the limelight, so that they should also get the share of the research and share of the resources also. Then only this country will grow, and the prosperity will go to the root level. Like Honorable VC was saying that they are catering near 20,000 students, which I think if we combine at least 5-10 IITs, they are not doing this, because we only cater only few thousand students, right? So we have to reach to all the institutions and bring those research aspect also, so that this country should get benefit of those fundamental research or the applied research which is needed for this country or for the industries. So thank you. Thanks for invitation. I am really excited to see for this conference, and this conference is integrating so many things: the fabrication, the monitoring, the sensors, the 3D printing, and then the characterization. So I think it's a full aspect of the mechanical engineering is maybe will be covered in this conference. So thanks the organizers for such a short period. I think 10 days back or 15 days back, you have contacted me and bring this up to this stage. So thank you for this wonderful efforts. And I again congrats to you, all your team, and I am looking forward. Thank you.
Padmini madam.
Yes,
I will take 3 minutes for our
Yes.
department, because Dean and VC are busy with their activities. That could be the reason
Yes.
I
Yes.
postponed my talk.
Thank you, sir. Thank you very much, sir.
So, good morning to one and all. So, experts from industry and the primary institutes, my dear colleagues, dear participants, good morning to one and all. I'm Professor M.R. Sachinarayana, HOD Mechanical Engineering. Warm welcome to all delegates for today global virtual seminar on exciting manufacturing automation 2020. At the outset, I congratulate the convener, Dr. B.S. Prasad, and coordinator, Dr. S. Sandeep, came forward to organize today global virtual seminar on advanced topic, advances exciting in manufacturing automation. So prior to that, I wish to apprise about the department. It is my customary duty to apprise mechanical engineering department for the benefit of the participants. Department of Mechanical Engineering, already our Honorable Vice Chancellor stated that it is the oldest department in the entire GITAM University, 40 years old department. Department of Mechanical Engineering offers BTech Mechanical Engineering, Mechanical Engineering with Artificial Intelligence and Machine Learning, Mechanical Engineering with Electrical and Hybrid Vehicles, Mechanical Engineering with Smart Manufacturing. Since 1920, these are the 3 different specializations we are offering with mechanical engineering. Similarly, MTech, Manufacturing Technology and Automation. Our Board of Studies also approved MTech Mission Design and Robotics at GITAM Hyderabad, apart from the research programs. In fact, department faculty have been involved actively in the teaching learning, undertaking research projects funded by various funding agencies, consultancy projects, publishing papers in peer-reviewed journals. So, Department of Mechanical Engineering has best practices. In fact, every year, department has been organizing every year Dr. V. Bhujangarao, endowment lecturer, who worked as Director General, retired DRDO. In the name of Dr. V. Bhujangarao, endowment lecturer, we are inviting experts from India as well as abroad. Invitees already visited from Greenfield University, University of London, similarly from IIS Bangalore, IIT Chennai, IIT Kharagpur. So DRDO directors, DRDO, ISRO. So like that, people have visited GITAM and delivered Dr. V. Bhujangarao endowment lecture. Other best practices, we are giving Dr. APJ Abdul Kalam Gold Medal for best outgoing student every year during convocation. So this is another prestigious award will be given to the mechanical engineering students. So like that, there are many best practices are there. Apart from the curricular activities, a department also encouraging students to participate in the core curricular activities, for which we have constituted 3 clubs. That is GITAM Automotive Club, GITAM Aero Modeling Club, GITAM Autodesk and Engineering Club. Apart from the 3 clubs, 3 chapters also there in the Department of Mechanical Engineering. One is Institute of Engineers, this is a World Society, and Society of Automobile Engineering, and Indian Society of Technical Education. So like that, students also getting good placements from different software companies as well as the core companies. For the last 5 years, very good companies have been visited GITAM, like Mahindra, Maruti Suzuki, Fiat Company, Hyundai, Tata Advanced Systems, Saint, formerly known as Infotech. So like that, many companies have visited GITAM recruiting mechanical engineering students. So these are the different strengths of the mechanical department for the benefit of the experts, particularly from IIT Ropar and the doctor from Dr. Arvind from Hyderabad and another experts. Coming to the theme of the program, in fact, manufacturing technology and automation, already rightly said, our university has proposed to start in this particular academic year MTech Manufacturing Technology and Automation. So in the first year itself, all seats are filled because that is the indication for good opportunities in the automation. In fact, our Honorable Prime Minister of India, Narendra Modi, recently has announced Atmanirbhar. Atmanirbhar is nothing but self-reliant. It means we people focusing on Make in India concept, manufacturing in India, in general manufacturing as well as defense manufacturing, for which 20 lakh crore have been allotted in order to make in India, in which they are giving priority to the MSME. We are focusing on micro, small, medium enterprises. So in the wake of coronavirus pandemic. So automation definitely it is required at different levels. It could be a metal landing, or it could be an inspection, or quality control, or welding, or like this. Automatically, the automation increases productivity, safety, and profitability. So these three are very important. That's why we have to create ecosystem. That would be the reason in the mechanical engineering, all laboratories are well established, good infrastructure in terms of, for instance, take ICE engines lab. So engines lab completely PC-based ICE engines. For machine shop, completely latest equipments. Recently we visited Mahindra at Jahirabad in Telangana. So whatever latest equipments are there, softwares are there, we have in the GITAM mechanical engineering. So these are the strengths of the mechanical engineering department. Really, this is the good platform for mechanical engineers to gain latest knowledge in the area of automation and manufacturing technology, which is there in the cutting technologies. So really, we are thankful to the resource persons accepting our invitation. Really, we are very happy, sir, for your presence and delivering lectures to the participants. Also, we are thankful to the participants from the abroad also, because according to statistics given by convener, there are 5 countries from 5 countries are participating in this particular webinar for global purchase seminar. Really, very good news to me, because in this particular month, this is the 3rd event. In the first week of August, we conducted webinar on condition monitoring by inviting experts from Adani Group from Maharashtra. In the second week, we have conducted another webinar on machine learning with the support of Dr. R. Banpavan, the expert from United Arab Emirates. He has delivered lecture in this particular machine learning. So this is the 3rd event in this particular month. Really, we are thankful to all colleagues for supporting the Department of Mechanical Engineering. I thank organizers for giving this opportunity. Thank you, madam. Thank you, convener. Thank you, sir.
Thank you, sir.
Thank you very much, sir, for presenting a 3-dimensional or multifaceted perspective of the very strong mechanical engineering department in GITAM. I also would like to thank Dr. Naveen Kumarji. Bahut shukriya, sir. GITAM is very happy to have your knowledgeable presence. And thank you for pinpointing at specific technical aspects on this occasion. Many hands contribute to great tasks. So all of you have understood. It's time to vote of thanks by Dr. Sandeep Alankaran. Sandeep, sir, over to you.
Sandeep? Sandeep, are you there? Sandeep?
Audible.
Voice is audible.
Yes, yes.
So good morning to you all. On the behalf of Department of Mechanical Engineering. So shall I start?
Yes, please.
Yeah. On behalf of Department of Mechanical Engineering, I deem it's a great honor and privilege to propose vote of thanks for global virtual seminar, these exciting advances in manufacturing automation 2020. Firstly, I would like
Sir, HOD sir, is my
Maybe
voice
there
audible,
is a
sir?
technical glitch.
Can I go ahead with sir?
Yes,
I request
go ahead.
ESP
Go ahead.
sir
Yes.
Please propose vote of thanks.
Yeah. Hello.
Sandeep, please continue.
Yeah. Thanks sir, for the interrupt.
Some problem is coming.
The great vote of thanks.
Yes, Phil. The signal is very weak. Go ahead.
Exciting manufacturing
Sandeep,
development.
Sandeep, can you stop? I will continue. Sandeep? Okay, Padmini madam?
Yes, sir. Please proceed,
Okay,
sir.
sir. Yes, sir. On this occasion, I, as a convener EAMA 2020, I wish to propose vote of thanks. Now, first, I would like to start with our Honorable Vice Chancellor for accepting our invitation within a short notice, for gracing his valuable presence in this occasion. We would like to thank Professor Sivaramakrishnan Garu on behalf of Mechanical Department for gracing this function today. Thank you, sir. And we would also like to say thanks to our Dean Engineering, Professor Vijay Shekhar Chalabone, sir. In spite of his busy schedule, he is able to take 10 minutes of his schedule. Thank you for your presence in this occasion, sir. And we would like to also thank our leader of the Institute of Technology, Professor C. Dharmaraj Garu, for extending his support throughout the organization of this particular event, sir. Thank you, sir. And particularly, I'm very personally, myself and Sandeep, Padmini Madam, would like to thank our beloved HOD Professor Amara Satyanarayana Garu for giving us enough freedom to go ahead with this particular event, sir. We were very much thankful to you, sir. I'm saying on behalf of everyone, very much thankful to you, sir. Thank you, sir. Next, coming to the experts, Professor Naveen Kumar, sir, from IIT Ropar. Thank you very much, sir, for accepting my invitation just over a phone call. Thank you very much, sir. You gave everything over the phone call. Later, I have submitted the protocol, like I have submitted a formal letter and everything. But before that, you have accepted me without any condition, without anything, sir. Thank you for giving this opportunity for us to have you in GITAM, sir. Thank you. And the busiest doctor in the Hyderabad city, Dr. Arvind, sir. Thank you for your presence and acceptance for our invitation. I hope definitely our students are going to be enriched with your sessions, sir. And one more thing, sir, another expert from GITAM, Vigyan University, Professor Venkatrao, sir. He is also busy with his academic schedules. He is one of the academic dean at Vigyan University. In spite of his busy schedule, he is also gave his acceptance over a phone call. And we named it this particular session as a global because of the presence of the Fayed Muhammad Turan from Malaysia. We also extending our heartfelt thanks to Dr. Turan for accepting our invitation, being part of this EAMA 2020. And I would like to thank all the panelists from the senior professors from Professor Surendra Garu, Professor V. Srinivas Garu, Professor Narendra Garu, and Associate Professor V.N.S. Viramna is the coordinator for the manufacturing automation course, and Dr. D. Sivaprasad. And more importantly, within a short notice over the SMS, Vice Principal, GITAM Dental College and Hospital, he also accepted to be part of this particular session and this particular conference. And he is the person who initiated the registration from the GITAM Dental College. Thank you, sir, for giving the support through your students. And last but not the least, I thank entire management of the GITAM, entire society of the GITAM who are part of this particular thing and who are encouraging me for everything. And I want to mention one particular name, Professor Raja P. Papu, Director, Research and Consultancy. He talks very less, but he gives a very important information. So thank you, Raja Papu sir, for giving your insight at every stage of this particular thing, sir. So I wish all the participants, you are going to have a happy learning on the virtual platform, which is provided by the GITAM University. Thank you, Dr. Padmini, for giving this opportunity. Thank you, HOD. Thank you.
Thank you, sir. Ladies and gentlemen, with this, we mark a very brief close down to our inaugural session. But then in a short while from now, we will be moving ahead to commence our session 1. Before that, here's a very brief glimpse of our GITAM. GITAM is not only a deemed to be university. GITAM is all about aspirations, dreams, achievements. GITAM is all about people and their dreams. GITAM is with all of us even during tough times. GITAM is an empowering strength, and we are very happy and proud to be a part of GITAM family. In a short while from now, we'll have a glimpse of our GITAM. Please stay intact.
Okay, madam.
I request all the members to just stay intact. We are in the process of playing a brief video. I request all of you to be intact. Thank you.
Is it visible, madam?
Sir, screen has not yet popped up, but the message has popped up, sir. I think we can take Suresh sir help in this regard.
Is it visible?
Not yet, sir.
Yes, yes.
One second.
I once again request, dear ladies and gentlemen, please stay intact. We just request you to be intact for a few moments. Thank you.
Madam, is it visible?
Yes, yes.
Sir, screen sharing message has popped up. Yes, sir. Video hasn't popped up yet.
Oh, it is coming
Audio
up.
is-
It is coming up.
Coming,
Okay,
madam.
Business, is it visible?
It is visible.
Okay, sir. Thank you.
campus is really good. There are very good opportunities for research here, which is the basic thing. So if anybody is interested in PhD, because there are a lot of UGC grants that are there in this college. So it's really great for research.
The Lucknow life was very different. I was not able to express myself. Like it was very different. Geetam వచ్చిన తర్వాత because it
కాలేజెస్ ఎన్నో ఉన్నాయి. వాటన్నిటిలో కొద్ది కాలంలో #1 ప్రైవేట్ యూనివర్సిటీగా వెలిగింది అంటే
I was coming into the university and I was really impressed with the infrastructure. Fabulous infrastructure.
GITAM University.
Okay, madam. Over to Padmini, madam.
That was a very brief glimpse of GITAM.
Sir, is the voice audible?
Echo is there, but okay.
Just 2 seconds.
Now is it okay, sir?
Okay. You switch off one of your devices. It's better.
Very happy being a part of GITAM. Also very happy. Goosebumps really come out whenever we come to know about GITAM or we see anything about GITAM. Because it has become a part of our life. It's a way of life, in fact. Ladies and gentlemen, we are going to now commence our session. Without any delay, I deem it as a privilege to invite Dr. Naveen Kumar Ji, Associate Professor from the Department of Mechanical Engineering, IIT Ropa, to deliver a talk on investigation of engineering properties of biological materials. So our session is commencing in a short while from now. Dr. Naveen Kumar Ji, we welcome you, sir. It's over to you, sir. Thank you.
Thank Dr. Padmini, and thank all the organization once again to give me this opportunity. I hope I am audible to all the participants.
Yes, sir.
Okay. Yeah, so I will, without any delay, I will share my screen. Let me see. Desktop. Just a minute. Where is the desktop?
Sir, if any issue, please share the PPT with me, sir. I will.
Yeah, I'm sharing the PPT, but where that PPT is?
Click that green color icon, sir. That is visible on the screen. Share screen. Just now. Can you please see your WhatsApp, sir?
Yeah. Yeah, that I have done it, already done. I have reached the general. Why this is asking privacy. Motion of screen content on 3 basic desktop share. Share. Recording. Why it is taking? Oh, that will be better. I am attaching to you, right?
Yes, sir. That is better, sir.
Oh, that's a folder. It's difficult to run some of my videos. I don't know.
Sir, can I call you, sir?
Pardon?
I will call you, sir. Please take my call once.
Yeah. Hello.
Sir.
Yeah. So what is happening?
If you can put the green color button, share screen.
Yeah, I have shared screen. Then I reach the desktop.
Have you reached the folder, sir, or the document which you
No,
want to share?
that's I am not able to reach. It is taking the open system preference, security and privacy.
Yes, sir. First to stop the screen, sir. Then go to a particular PPT or file what you want to share.
That's the not coming up here, right? That's the issue is that it is taking the privacy.
There is no document is saved on the desktop, sir.
Desktop, it is there, but
file is available on the desktop, sir. Keep this open, sir.
Just a minute. Why it is taking to the privacy?
Sandeep and Padmini telecast 1 or 2 videos.
Why this is when I go green button, it's taking the either desktop or PPT, but then it is asking allow to share your screen, allow share system preference. It is asking, yeah, it is asking system preferences. So I have given, but then advanced. No. File and folder. Where is my files? Oh, that's not another. PPT is very big, so it has so many videos also. I will do that. I think, let me see if I can attach it. Your email ID is that
Thank you very much for your patience, ladies and gentlemen. I request you to give us a few moments so that Naveen Kumar ji can just connect to the corresponding files and start the talk.
Hello.
Yes, sir.
Can you see my screen now? Is my screen is visible?
Yes, sir. We can see your screen.
Yes, sir. We can
Okay.
see your
It is visible.
I'm really extremely sorry. This has never happened, but I don't know what was happening.
Please continue.
So yeah. So here the work which I want to convey here. Just a minute. I will take just. I think so. So what I will talk about how this biological materials properties, in particular the engineering properties, are fabulous, and we can take a lot of inspiration from them, and we can design a lot of devices or instrumentation. So that's I will talk about it. So so what is happening is. Yeah, so this is the IIT Ropar campus, a new campus come up near to Chandigarh. It is near about 40 kilometers away from Chandigarh, but we have 500-acre campus, and new campus has come out. So and then I will talk about some of these insect, how these inspiration can come up, because nature has evolved thousands years back, so they have the optimized system. So whatever you design, if you have inspiration from the nature, it will be the best, because nature has designed the system which is evolved over the thousands of years. So we cannot have a doubt about the designing of it. So we will talk about the spider web, honeybee, stingers, how beautiful they are, and the mosquito, the painless piercing, how they do, and dragonfly wings. They are coming up in micro air vehicles. And then I will talk about the nail, bone, soft tissue, and how they are important to know. So what is happening is the spider web, if I can show you, please let me know if this video is, this video is visible?
Yes, sir, it is visible.
Yeah, so this is a spider web, a spider who is weaving its web. So it is at very slow speed, near about 10 times slow speed. So you can see how beautifully she is putting the each of this web in a parallel thread, and she do it very quickly within a few minutes. But so meticulously she is putting it, and so nicely she is weaving. It's very difficult to do it through the machining process, or if we want to do by some mechanical instrumentation. So that's the learning which we should have. But I will talk about how when she will weave this web, how nicely this engine property of this web will come up. So this, you can see this in the actual motion. This is the speed which she adopt by weaving this. And then this is a, it seems that it is not very durable, but it's a durable. If you see in stormy conditions survive, and even at high humidity it survive. It has some specific property. That's how it's do it. So what we have done is we do very simple experiments. So we have taken the spider web on a glass sheet, and once you bring this glass sheet near to the web, it is automatically attached because it has those adhesive natures of the web. So then you bring it in the lab, and then you do some experimentation. So what we have done is we have used the indentation techniques. So you can see this figure number 3 is showing a small indent we have created on this web. So there are two types of webs are there. The radial thread, which is little bit thicker. So this is the radial thread, and this is the spiral thread. The spiral threads are thinner thread, and she put the gum spot in between. Also, you can see how nicely gum spots are placed during the weaving. She put it so that insect will come up and will be attached to this. And then she has this the joints. So joint is not single joint; it's having multiple joints, so that failure chances will be less. And then here, figure 2, I am showing the red and blue curves. So red is showing the indentation depth on the x-axis. So it is a load displacement curve. So the displacement is given in the x-axis, and on abscissa we have given the load. So the radial thread, you can see the indentation depth is less, and the spiral indentation depth is more. It means the spiral is more softer or has less strength or hardness than the radial one, right? So that's the one conclusion is coming up. The spiral is more softer and radial is more harder in the crude way, we can say that. Now coming to, and then what we have done is, this is a beautiful web which is come up near to our lab. So we have taken our instrumentation there, and we try to see how this, the characteristic of this web is sustained when this windy condition, extreme storm is there. So then what we have done is we have put the laser spot on this. We have this laser vibrometer, so you can measure the vibration of any structure by using this laser spots. And then what we have done is we try to see the vibration of the radial and the spiral thread, which I have talked about the here in this. So these are the radial thread. Radial threads are actually the give the structural strength, and these are the spiral threads, right? So we try to see the vibrations of these two threads. So you can see the spiral thread is given in the blue and radial is given in the red. So it is a vibration spectrum or the vibration response. So here we have the displacement or velocity, and on the x-axis we have the time. So the vibration which settle quickly has more damping. So you can see this spiral thread is settling very quickly. It means it's a higher damp than the radial thread, right? So in the previous slide, I have shown that the spiral is softer thread or the softer material than the radial thread, but the spiral has higher damping, right? So these two special characteristics of these two threads make it so beautiful that it can sustain when the insect strike it. So why it is needed? When the insect strike, it is strike generally, it is strike at this area on this spiral thread, because spiral threads are large in number than the radial thread. So spiral thread has the higher damping but low strength, whereas the radial thread has higher strength but low damping. It means when the insect strike on this web, it generally strike on the spiral thread because they are more in number. So when it is strike, the stretching capability or the damping capability of the spiral thread should be high, and it's come out from the experiment the same thing, right? So it means when she weave it, she has those engineering fundamentals in their mind, that which thread should be higher strength and which thread should be low strength, and which should be higher damping and which should be lower damping. So this is the and she's weaving it thousands of years. But if we design an engineering structure like this, a flexible structure which we want more strength and higher damping, you can have this inspiration from this web. So you will not believe me, this all are my BTech students, Anurag, Vijay, Shashank. They have done this study. And then one of my postdoc, Dr. Rakesh has written this paper, and we got very good publication of this paper. So it is not true that BTech students may not do good research. If you give them a simple task, they can do a really good research also. So then our work is published in some of the German magazines and in the media also. Now, what is happening is, this is not only the structure has such a beautiful engineering property. When generally what happening is, the spiders, some of the spiders are blind, they cannot see. But how they then catch the insect? They catch the insect through the vibration signal, which is get transmitted from the when this insect strike, the vibration signals are created, and that get transmitted. So you can see this is in our lab. We have this grown up the web, the spider. We have created a favorable condition so that we can check how she is getting those signals, and it's useful in designing the sensors. So like you can see that I will again show you this video, that when we have put the live insect, she has followed this path. You can see she has followed this particular path, the straight path, or the lowest distance path to catch this insect. She has not gone at this place or this place to search where the insect is. So quickly, within fraction of seconds, she grabbed the insect. So how it is doing it, I will show you how this vibration signal get transmitted, and she get those signal information, and she process those signals and get it through these insect. So you can see that also here, that how quickly she's going there and catching the insect. But surprisingly, also that's true that when we put the dead insect on the web, she has not responded. It means she also has those flickering of those live insects. So what we have done is, again, we have put the laser vibrometer spot and try to see the vibration response, vibration transmissibility, which is coming out from this spiral threads and the radial threads. We want to see how these signals get transmitted from these spiral threads towards the center. The spiders generally sit in the center. So the transmissibility is important. So we want to see from this different thread how the signal get transmitted, and she catching those signal, and she know that where the location of this spider. So here we have done this the transmissibility at different junctions. These are the junctions, these are the spiral, and we try to see that's how it's get transmitted. So you can see this the vibration transmissibility ratio. We have come out. Those BTech student who has done the vibration course, they know the vibration transmissibility is very simple things. So then we get to know that how these signals get transmitted towards the center, and she catches those signals. And it is a very good study which convey that these vibration signals she is catching and then locating the prey. It means somebody is interested in development of sensor they have this inspiration, and people are working on the designing of such type of sensor which has the inspiration from the spiral thread. Many papers are already, I have seen 3-4 papers from the other universities people are working on. So this work is we have published in the Philosophical Transaction of Royal Society A, which is the oldest journal in the history of English speaking words. Newton has published his paper in this journal. So this is the very reputed journal and about 200 years or 300 years old journal. Now, again, I am coming to another insect, the honeybee and wasp. They have the stinger. So what is the stinger? This back channel which she bite when she is threatened. So what is there? So when some prey she is threatened or feel that attack is there, she take out this stinger and she bite it. What is happening is during the biting she insert the venom in the prey, and this inserting mechanism is beautiful mechanism. How she do it, we will show you. So what we have done is this stinger which I have shown is about 2 or 3 mm. So we have done the CT scan of it and try to see the internal structure. So this is the figure A showing the CT scan of this stinger, full stinger. Initial 2 figures are the CT scan of full stinger, and then the second figure is showing the inside of these, because CT scan you can get the inside view also, inside information also. So here what is happening is we have seen that there is a guide rails, all lancet type of things on which the upper structure is sliding. Right. So what is happening is when prey is coming near to her, she is sliding the upper portion on this lower portion on this guide rail, and there is a sac of venom is here, right? So because this sliding motion, there is a negative pressure developed here, and the venom goes to inside the prey. Through this channel, micro channels. So you can see this micro channel and orifice is there. So it is opened and that inserted in the prey. So this mechanism of the inserting the venom in the prey is very beautiful mechanism. But yes, it is of course the prey or the person who is they bite is feeling the pain. Pain is not because of this the penetration. Pain is because this venom get inserted, which is creating a lot of pain in the prey or in the person who they bite. So this insertion mechanism is very interesting and has the inspiration that. So what we have come out, and then we have done all those see the property. It is not uniformly distributed structure. It is have a lower modulus than at the base, which is also true because you don't need so much high strength at the tip. And one more thing which we have investigated is that what happening is then when they penetrate or when they bite, they have put some particular angle from the vertical. So they put near about 10-degree angle from the vertical to bite or to insert the stinger. Why they do it? Because we have shown it here, different figures, 90 degree, this angle is 90 degree, 45 degree. This biologist has conveyed that this angle they are putting, but what is the angle and why they are putting is they have not conveyed it. So when we were doing literature survey, we try to see, so why they are putting it. We have done the finite element simulation and see the stresses which are coming on this stinger. We find that the lowest stresses are coming when this angle is about 6 degree or 10 degree. Within the 10 degree, the stinger gets the minimum stresses on its surfaces or on its structure. It means those biologists which were saying that they are creating a small angle from the vertical to bite because they get the maximum forces through this angle and their stinger will not be break. So these insects are doing it. They have behind the binging concept, and that's also we used. So we have proposed this. We have filed the patent for this. The bioinspiration micro syringe needle for the drug delivery. So here what we have proposed is there is a simple sac, and then the drug is pre-filled, and then you have to take out the just slide this upper portion, and then drug can be released in the patient. So that's the concept which is inspiring from the nature. So here we got this Nature publication scientific report, which is this work was talked about. So now coming to one more work which we have done is on the painless piercing of the mosquito. You know this, all the people have find that mosquito bite without the pain. So how they bite, what they do is they have the so much beautiful capabilities. They have the CO2 sensor. They locate your arteries or vein, the blood vessels, and they also has the numbing agent. They little bit put it so that you can don't feel the pain. These all are reported in the literature. But they also do this little bit vibration of very low frequency, say 5 Hertz vibration, when they are penetrating it. So, and that's these combined effects is making so beautiful that you do not feel the pain. And how this is happening, I will show you. So this is the proboscis which go inside. This is the hollow structure which get pierced, which is known as labrum, and it has the hollow tube. So when they suck the blood, it go throughout this tip. Now you can see that's how this bite it. Just a minute. Yeah. So here you can see it is searching the blood vessels. And once they search the blood vessel, you can see this is started inserting, and it is not a quasi-static process, it's a dynamic process. If you can see that, and then it's go inside the blood vessels, and then still it is little bit vibrating at certain frequency because it's a viscoelastic material. They change the frequency because they can change the modulus or the structural property, and they take out the full blood by piercing it, right? So that's how they do it. But now, what is the process or the mechanics behind it? Why we do not feel the pain? So that's happening here. So what we have done is we have taken out this labrum, the small, which is hardly of say 150 mm of 150 micrometer of length, and hardly 30 to 40 micrometer of width. This is the labrum. And we do a lot of indentation on it, right? So we have make a grid and do the about 100 indentation on this, about 50 micrometer length and about 40 micrometer of width, and try to see how this structural property variations are happening on this. And also we have done the dynamic test on this. So here we have done the quasi-static, and here we have done the dynamic, because this labrum is vibrating structure, so you should know the dynamic property also. So once we have done, so what we have done is we have done taken all the result of this indentation test, means we got the modulus and hardness at each point, and then we mapped it, or you can say we have summarized the property on all these points. So you can see that so the modulus is not very high at the tip, which is contrary to our belief, or our we were thinking that it will be high, but it is high at the distal end, right? So why this happening? We have repeated so many times this experiment. We thought this is not correct. The tip should be hard. But then we have when every time we got this result, so we got it that you see these are the ends are like corrugated. They are folded at the edges. Why this is happening is because during the penetration, it needs sufficient stiffness so that it should not bend. So these ends are little bit harder or high strength than this tip, and tip strength is sufficient, which is about 0.02 or 0.03 of gigapascal, which is sufficient to penetrate, and which is more than the modulus of the skin, but sufficient to just penetrate. But during the penetration, it should not bend. So they have given this corrugated structure, which is having a very high strength, and that's why it is not bending. So if it is like same thing, if you fold a paper and then try to bend, it is difficult to bend because you are increasing the stiffness by corrugation or by folding. So same principle is here. Nature also has followed that same principle. So it is a curved structure or folded here, and which make it more strength, and that's why it's not bending. And also they keep on vibrating at different frequency. At low frequency, we have checked this 5 to 10 hertz frequency. So you can see that they keep on changing its modulus, so that whenever they need higher modulus, they can little bit tune it, the modulus, so that they can get the sufficient strength of this. So that's why they are vibrating it. So again, this work is one of my BTech student who is now completed the PhD in Iowa State with the Professor Bharat Bhushan from the Iowa State. We have done this work and we have filed this patent. Also, so you can see the bioinspired needle, micro needle. This is used to take out the blood. Earlier, we have given you the inspiration from the nature about the honeybee, which is used to supply the drug or the for the drug delivery. But here, you can take out the blood through this system. So it is not uniformly, material gradient should be there. There should be some vibration, should be there, low frequency vibration. And that's that can be done with the help of by taking the inspiration, and the material strength may not be needed. We have at present the metallic needle, the stainless steel or different materials, but which is not needed at all. You can have a very softer material and it can penetrate if you have that frequency of vibration. So that's the nature is doing. So people are working on it, and we also have planning. We are also working on it and planned a lot of things for it. So now how this the dragonflies, which have a micro air vehicles, so people are working it because now the structures are the drones are of micro size, so that they can spy the enemy. They can enter in the room by the windows or by the doors. So a lot of applications are coming, but because nature, this dragonfly has the unique capability. If you have seen them, they can suddenly turn around. They can take a 180 degree turn. They can change the altitude at different velocities. So and they have very high velocity also. So that's the inspiration come up. People are working on. So what we have done is we try to see how this when the dragonfly flip their wings, how the streams are coming on the wings, because wing design is also very important and a very crucial element in the micro air vehicle design. So people are taking the inspiration from the dragonfly, but we should know this, how this dragonfly's wings has those capabilities or those engine properties. So here we are showing these different modes. What is mode? When anything vibrate or anything move, they have particular structure or particular shape. So these are known as mode shapes, and we are showing you the different modes. And these we have taken the high-speed cameras and do these experiments. These are all our experimental work, which I am showing you. So we have got different modes, and then we also got the strain distribution on this mode, so that we can know that where the maximum strains are coming on these wings, so that the failure chances of wings would be less. And if you want to attach some sensor on these wings, you can do that also. So these are the strain distribution on this. So first mode is bending mode. So clearly on the base strain will be maximum, which is coming out through this experiment work. The second mode was the twisting mode. So at the edge strain is coming out maximum. Third mode was also twisting mode. Fourth and fifth mode are complex mode, which is mix of bending and twisting mode. So yes, so here we are plotting the strain distribution on the wings, so that inspiration can come up and wings can be designed for micro air vehicle. Again, we have published this paper in the Philosophical Transaction of Royal Society. Now, one more work which is related to human fingernails. Can we check the human fingernail, the diabetic patient? Can we from the nail, can we take the nail sample and convey that this is the patient is diabetic? So we have done a lot of sample collections. We work with the hospitals, and we have collected hundreds of samples. And then we come out, yes, we can give the indication of the diabetes, even the progression of diabetes through this nail. So what is happening is there is a glycation end product deposition of this on this human nail. And if you do this mechanical testing, biochemical testing, you can find out those differences. And we have shown in this work that nail also convey those property that this patient is having the diabetic or not. And then again, this work we have published. And then we are working on this bone strength. Why we are working on this bone strength? This is the work. I will show you very small work, because I think my time is about to over. So how much time I have? I think another 2-3 minutes, I think. Or over. I think I have taken sufficient time, so I should
Yes, sir. Please go ahead, sir. No problem.
Okay, I will take another 5 minutes and show you what we are doing it here. So why bone is important? This is the population curve. So upper is showing the Indian population, and lower one is showing the US population. So here the first is showing the Indian population pyramid in 2000. So the yellow line, above the yellow line, this area is showing the number of people who is crossing the 50 year of age. Means those people who are above 50 years. This population, the tip of this pyramid. Then it is changed to, in 2020, now it is this much. And in 2050, it will mean this much. Means our population become more older. We are no more, we will be the young country, we will be the older country in 2040 or 50, right? It means the problem, so here, this is the US. US is here in 2020, which will be, we will be same like US in 2050 or 40, because we are growing very fast in the terms of the old age. So you see, and our population will be large, very large in comparison to US. And why I am showing this, once the older age come up, this musculoskeletal system, a lot of issue come up in the bone or tissue. They get deteriorate, and that's the issue which come up after the 40, after the 50 years, or even earlier in the particularly in the females. And here, this is a lot of burden on this economy. So many people are suffering because of the musculoskeletal diseases. They cannot talk, they cannot walk properly. They have the abnormality in the bone or tissue. So people has to see this in coming years. This area is having a lot of potential. So we should know this, why this is happening, why this property get deteriorate of these particular skeleton system. I show this slide to all the mechanical engineers. See this skeleton system. We have all those mechanical things which a machine has, or a mechanical design which we put it. So you see, we have all the joints, even more than the whatever we are putting in the machines. We have the gliding joint, we have the hinge joint, we have the pivotal joint. Here we have, even God has given all these joints, but unfortunately we are not recognize those joints. We give the examples, show the example to the students that you see this machine, what are the joints, but we will never convey them that our body has all these joints. If you show the skeleton, all these joints, cantilever, all those examples are there. So it is needed that, because and all this basic principle of mechanical engineering apply here also. So you see the loading condition when we throw a ball, all these loading conditions are simultaneously the axial load, the tangential load, the shear deformation, all this happening here, which is more complex than even in the machine it is happening. But unfortunately, we do not give the examples. So, but what is happening is, when you have the normal loading, the failure chances are low, but when you have the abnormal loading, the chances of failure is very high, in particular the hip fracture happening. And this is a very serious concern. Once the hip fracture happens in the old age, the mortality is very high. People, surviving rate is less, right? So what we have done is, the clinicians has the issue that they have one tool which give the bone strength, which they measure the bone strength, that your bone is good or not, is the DEXA. It's an X-ray based technique, but it has the limitation. They always complain, clinician always complain that DEXA is not giving the clear indication or clear message of the bone quality. So here, what we have done is, we have done the two more investigation. We have done the CT scan of those bone samples, and we have measured the bone strength or bone modulus. You can measure it by using any of the mechanical system. So you can see that these two patients, which are having the same DEXA score, T score, minus 2.9, minus 2.9. But if you see the CT scan, this patient bone is more fragile, the last patient, with the first patient, even though they have the same DEXA. And when we have done this mechanical testing and find out the modulus, we surprised to see that this bone is, even though the DEXA saying that its bone is not good, DEXA is minus 2.9. And here is even more higher, it is much lower than value, means minus 4.2. But if you see the strength and the CT scan or the volume fraction, it is giving the clear indication that this bone is much better than this bone, right? Which DEXA cannot differentiate. So now clinician also is agree and accepting that there is something lagging in the DEXA, or when they do this in a clinical investigation through the DEXA, some more tools are needed which can give you clear information of the bone strength. So we are working on this. We are doing a lot of investigation of the bone strength, and we try to see what is lagging. So here so you can see the BMD, which is bone mineral density, which DEXA give. Here the osteoporosis and osteoporosis type 2 diabetes, both are coming out same. But when we have done this modular study, it's coming out different. Means there are some more investigation, means mechanical investigations are giving more correct reading, but it is also true that you need some basic screening tool, means DEXA, and then you do some more investigation, you can find out very interesting property of this bone. So we are doing a lot of modeling, simulations, investigation of the bone, and try to see how this we can help these clinicians, how this crack is propagating. So I am quickly, and then how these implants can be designed. So all this information is really very helpful to these clinicians, so that they can know. You can see the two implants, which this is the conventional implant type 2, which is used, but this is the new implant which is designed by the clinician, and we are testing it. So there's a lot of scope of working in this area, and we have a lot of things which can be designed or has the inspiration. Then we have this high strain deformation. And then beyond the soft tissue, we are working on this, right? So what I'm saying is there is a lot of inspiration you can take in designing of the engineering tool devices or instrumentation by using this even the from the natural thing, right? So thank you for your time. I have taken a little bit more time. I acknowledge IIT for giving me such wonderful facilities. PGIMR is we are working about 15-20 clinicians with them. AIMS Delhi, number of clinicians are working with them. AIMS Bhopal, Henry Ford Hospital, US, RPI US, these are all are my collaborators. They are working with us. A lot of investigations are also doing there. DST is funding us, DRDO is funding us, European Union Orthopedic Societies who are funding us, DBT is funding us. So I thank for all those funding agencies giving us the funding so that this work is coming out. And all this work is done by my student. I am not doing any experiments, all my students are doing. So this is the contribution of all my wonderful students. Both the postdoc, my PhD student who has passed out, Karanveer and Sukhjit has done a very wonderful job in Karanveer in UPenn in US doing his postdoc, and all those my current PhD students and all my lab supervisors who have done this. So thank you for your time. I hope you got it some interesting things, and I encourage anybody want to ask some questions. You are most welcome. Thank you.
Thank you very much, Dr. Naveen ji, for revealing to us an entirely different panorama of mechanical engineering through spiderweb articulation, human fingernail quality, analogy between human anatomy and mechanical engineering, stress strain analysis. It's over to the participants now. Question and answer session. We have some questions which have popped up in question and answer box. In case if anyone has any Q&A, they will be responded to by sir. With the permission of the conference chair, I would be reading the couple of questions. Naveen sir?
Yeah.
Naveen sir, is my voice audible to you?
Yeah, very much audible. Please go ahead.
Okay, thank you, sir. There are many questions which have popped up here, but in view of time constraint, we can take up some of the questions. Professor Dr. Radha Krishnan Pradeep Kumar ji has popped up a question. Can the research finding on the angle of stinger and stress analysis be used for design of micro syringe needles also?
Yeah, so here really very good question. So that's what we were talking about. So this angle is also when you insert the syringe, when this the nurse or the medical staff. So that angle also important insertion, because nature they are doing this way. But it is more useful once we have softer syringe, because at present there is no need, because they have so harder syringe that it never be break. So, but angle only come in the picture when we have the softer, which people are working on it. I think very soon we have the softer type of syringe, and very micro needles are coming up. So then in that case, this angle will be really very important. Yes.
Okay, sir. We have another question from Mr. Ayush. Generally, damaged skin tissue can heal itself much faster than other soft tissues. We can wait for the natural healing, but the scar formation after healing is hard to remove, especially for patients with a large area of burn injury. The accelerated skin healing rate is necessary to prevent infections. What are the methods which can be applied in such cases?
Yeah, it's a really very good question. I will, I think, can you share? I have this work which is the tissue expansion. So tissue expansion is one of the method which these clinicians, like I have shown it here. So this is the tissue expansion. What they do, if the burning or the scar is there, so what they do, they expand the other tissue, part of the skin, and make it expanded, and then take it out and then place it on the place where the scar is. Like you can see in the first case, they have near the ear, a lot of scar is there, but they have expanded the skin near to skin and then put it. So that is the way that these surgeons are doing, and we have investigated this technique and see that how much stretching forces are needed, how much how the inside mechanics is happening, because the skin is made up of the fiber, the collagen fiber, the protein. So it is very important to understand it. So that we have done it in this study. So yes, that's the how these clinicians are doing. They are expanding it. So generally, the plastic surgeon doing this.
Madam? Hello? Padmini madam, are you there?
I think he is.
Sir, she has some connectivity issues, sir.
No connected. I think his mic is off. So if yeah, now
Yes,
it's on. Yeah.
Madam, doctor, switch on your. Madam,
Yes.
your voice is not audible.
Yeah, now
Dr.
it's
Sandeep,
audible.
are you with me?
Yes, sir.
Yes, sir. I am there with you, sir.
Yes, sir, very much.
Professor V. Srinivas sir is facing some network issues. I request Padmini madam to conclude the session.
Yes, sir. Thank you very much, all the attendees, for your questions. I hope all of you can understand that due to time issue, we are packing up Q&A session now. Thank you very much for your interest and all the questions posted. So this has been a very enlightening session and a completely different perspective and different angle of research, in fact, on spiderweb articulation and how it can be related to various research-based analytical methods in mechanical engineering, especially from the stress analysis point of view. That was an eye-opener, in fact, sir. Thank you very much. Moving ahead, the analogies developed between human anatomy, different bones and joints, etc. That was really very, very interesting. And I hope the participants, the attendees also had good information about all these aspects after attending and viewing the videos. Thank you very much, Naveen sir, for your time and patience. And we are extremely sorry to all the attendees. There were some technical glitches because of which we could not tune into the presentation in time. Extremely sorry for that, but we'll see to it that in the coming sessions, such sessions can be handled and controlled in a very effective way. Thank you very much, Dr. Naveen Kumar ji. Namaste, sir.
Thank you. Thanks a lot.
Thank you very much,
sir.
Naveen sir.
Thank you.
Thank you. Very much happy to be here, sir.
Thanks a lot.
Sir, I'll be in touch with you through WhatsApp, sir. Please check your messages, sir.
Okay, sir. We will be moving to our session 2 in a short while from now. Before that, BSP sir, as per the schedule, we are supposed to play some videos. Do we have some time or shall we move to session 2 now itself?
Madam, right now I have shifted to some other location. Can you please play
Okay,
the
fine, sir. We'll proceed with session 2 now, sir.
Yes, right. Okay, done.
I now request. Let me tell everyone that. Yes,
One
sir.
second, madam. Please
Yes, sir.
verify whether the next speaker is in the panelist list or not. Dr. Arvind sir, are you here, sir?
Yes, sir. Sir is here.
I'm there, sir.
Yes, sir. Okay, sir. Madam, please go ahead.
Sir is in. Yes, sir. Sir is in.
Yes, sir. Every time we need to confirm that. Huh? Okay.
Okay, sir.
Please display.
We are going to commence session 2 shortly.
Sandeep.
The resource person.
1 second, madam. Sandeep, can you hear me?
Yes, sir. Sure.
Can
Yes,
any one
yes,
of you?
sir. Yes, sir. Yes, sir.
Madam, give me some time, madam. 1 minute.
Sure, sir.
1 minute. 1 minute.
Sure, sir. Are you in the process of playing some videos, sir? DSP, sir?
Yes, madam. Actually, I am looking for a resume of the expert. That is already shared in the mail. One
Okay.
second. Sir, Surendra Babu, sir, can you share it on the WhatsApp, please?
Yeah, shortly.
Already green once checked, sir.
Is it happening? Sandeep, share the resume of the next expert, Dr. Arvind.
Yes,
Yes,
sir.
sir.
Sir has started screen sharing.
Yeah.
Yes, sir. I have.
I now request Professor Surendra Babu, sir, to introduce our resource person for session 2, Dr. Arvind Garu. Surendra Babu, sir, over to you. Thank you, sir.
Okay, madam. Am I audible?
Yes, ma'am.
Yes, sir, very
please go
much.
A very good morning to all the panelists, participants, resource persons, colleagues, and staff. It is a great pleasure for me to introduce Dr. Arvind UD, oral and maxillofacial surgeon, who will be delivering a talk on 3D printing and its applications in dentistry and maxillofacial surgery in today's session. Dr. Arvind graduated from SUS Institute of Dental Sciences in 2007. He obtained his post-graduation degree in MDS, oral and maxillofacial surgery from Paniniya Mahavidyalaya Institute of Dental Sciences in 2012. He is CEO of Dr. Arvind's Dental and Maxillofacial Clinic at Hyderabad. Dr. Arvind is working as a reader in the Department of Oral and Maxillofacial Surgery, HKES, Masalingappa Institute of Dental Sciences, Gulbarga. He is a faculty member of International Board of Oral Implantology, IBOI, Florida, USA. He is a recipient of Excellence in Dental Implantology Award in 2017 from Indian Health Professional Awards, New Delhi. Dr. Arvind is presently EC member of Association of Oral and Maxillofacial Surgery India, Telangana chapter since 2015. He is General Secretary for Telangana State Dental Surgeons Forum from 2014 to till date. He has published research articles in 4 international and 6 national journals. This is a brief introduction about Dr. Arvind. Thank you, sir, for having you with us today to deliver a valuable talk on 3D printing applications in dentistry and maxillofacial surgery. Thank you, sir.
Thank you very
much, sir.
Thank you. Thank you, sir, for introducing our resource person for session 2. Sir, Dr. Arvind, sir, I request you to take over this session and present interesting facts about the content, 3D printing and its applications in dentistry and maxillofacial surgery. Welcome, sir. Thank you.
Thank you very much, ma'am. So I'm just checking out whether I'm audible.
Yes, sir. You're audible, sir.
Yeah, I'm just offing my screen because it's actually coming in between my presentation. So thank you very much for the generous introduction, Surendra Garu. And first of all, I like to thank the GITAM University and also Balla Sudhir Garu and for giving me this opportunity to speak in front of you and to share my knowledge about what I have been doing in dentistry with the technology of 3D printing. So I thought it will be apt if I typed good afternoon, but it's good morning still. We are 10 minutes ahead, right? So very good morning. So today my topic for presentation is 3D printing and its application in dentistry and maxillofacial surgery. So first of all, most of the time we start off with the contents and all those things, but I would like to tell something about dentistry first in the introduction part. Dentistry is a specialty which actually deals with the diagnosis and treatment of the teeth and its surrounding tissues. This is not a definition, but this is a layman term which I have given such that everyone can get themselves adapted to this dentistry field. But what actually dentistry is, it's an art and science, where if dentist has to be a doctor, an engineer plus an artist. If he successfully does all these three jobs, then only he is a dentist. So all the dentists should always have a very good skill to obtain good treatment outcomes. So unfortunately, not all the dentists will have the same surgical